Hello and welcome. My name is Matt Stephenson. I'm a software engineer at Starburst Data. Today I'd like to talk to you about using Pulumi to create infrastructure automation magic with code. I introduced Pulumi to Starburst about a year and a half ago. Prior to my time at Starburst, I worked at several of the cloud providers and was very deeply integrated into the infrastructure as code space. I contributed to Ansible, I was a core contributor for Apache JClouds, and I've written my fair share of Terraform plugins. These days I lead the infrastructure architecture at Starburst. At Starburst we use Pulumi very extensively, including the Automation API. The Automation API is a library, and it's a bit of code that I've had to write several times before for other infrastructure as code tools. It essentially allows you to control via an API the actual Pulumi CLI itself. So that means you can do a lot of work with stack manipulation and provisioning of infrastructure just using a direct API instead of having to shell out to a CLI. This makes it very easy to do things like build a web service that provisions infrastructure, or write your own CLI that in turn provisions infrastructure. It also makes it very easy to perform complex CI/CD workflows, which is what we use it for primarily at Starburst. So how do you use it? Well, here's a set of code snippets. On the left is Golang, on the right is TypeScript. If you look at these code snippets, they both are very similar. They start off creating a stack, installing and configuring plugins, and then running stack operations. In this case, refresh, where we go and provision all of our infrastructure. In CI/CD, there's a lot of common patterns that I've seen develop in my time. So typically you start off building something that helps you with development and makes it so you can build and test your code quickly. So you're writing that around like a set of tooling and such that's not really designed the same as your traditional infrastructure as code tools. So you end up with like things that you end up with all these wrappers and API calls and such that kind of muddy the waters a little bit there. And you start having to deal with the environment that you're running in and such, and shelling out to various tools. Now, with Pulumi and the Automation API, you can kind of write all of this code the same. Since Pulumi has all these different language bindings, you can generally use the same language that you write your application code in to build your infrastructure. This allows you to really abstract away a lot of the environment and make it so your code is very homogeneous. It looks the same when you're building software versus when you're building infrastructure. So let's look real quick at like this potentially complex code boundary. How do we simplify it? So here's a snippet of code that kind of shows how in Golang to build essentially what the Automation API does. It goes out and it shells out to this CLI, but that's where like the easy part ends. Over time, you have to figure out how to serialize and construct all of the state and configuration to pass into the CLI. That of course grows as your infrastructure grows in complexity. You have to then also be able to parse and understand the output, even in the best cases, to figure out what your identifiers are. In the worst cases, you're going to have to figure out what this status code means from this shell script and what all of this output means in terms of how you're going to get rolled back to a known good state. So at Starburst, we decided to go with the Automation API in Pulumi. And we did that because we want our infrastructure to be ubiquitous and approachable. We want all engineers to be able to be comfortable going and making the changes they need to provision the infrastructure they need to for their product changes. We write a lot of our code in Java and TypeScript, and we use GitHub Actions for our CI environment. So we were easily able to go down the road of building all of our automation in TypeScript. At the time that we decided to go down this road, Java wasn't available. And, when you look at the complexity of our deployment, it's just gotten big in just a few years. So we've deployed across 20 different cloud regions, 3 different cloud providers. We have a very complex rollback process, and we have to make all of this happen within our CI/CD workflow. When we started our journey, we started off in a pretty painful place. We were using Terraform, we were using Argo CD, we were using Maven, Nothing was really working with each other or talking to each other. So we had this big menagerie of Docker containers, of GitHub Actions runners, of glue code just to get all of our build steps to work together. We even had a Slack bot that was thrown in there. These days with Pulumi and the Automation API, we've cut that down to just simply Pulumi and Maven. And so same looking code. Our build steps are essentially just somewhat broken up between building code and building infrastructure. The steps themselves look very similar. We have just a handful of Docker containers we maintain. Our CI/CD is well organized into GitHub Actions pipelines. Everything's a lot more manageable. So the simplicity is mostly due to like the ability for us to take and manage all of the Pulumi resources in a similar way as we manage our build resources. So here on the left, I've got some of our pipeline code snippets, and on the right, some of our actual Pulumi code itself. So in our build process, what we do is we take the artifacts at that specific point in the build tree, that specific commit, and package those up, the Pulumi artifacts. We put them in S3. And what that lets us do is make sure that when we're building, I might mention we have a monorepo. When we're building our software, we know that the application code that we're deploying is the same as the infrastructure code we're using to deploy it. We unpack that at a later build step and then use that to provision our infrastructure. On the right there, you can see we've got our actual stack configurations and such. We have really well abstracted away stacks for our infrastructure and our Helm charts. And of course, we deploy using Helm. So what we do is we kind of have an abstraction layer that brings us all the way up to getting to the point where we have Kubernetes and all of our infrastructure running. And then from there, we go forward with Helm and allow Kubernetes to provision whatever it needs to underneath itself, load balancers and whatnot. At Starburst, we have a really complex roll forward and roll back process because we do blue-green deployments. We completely eradicate and replace the infrastructure underneath our customers without them knowing twice a week. So that includes all of your VPCs, Kubernetes clusters, OpenSearch, whatever we're using, we're completely reprovisioning it across all of our data planes. We orchestrate this using Pulumi and the Automation API. And we have some very interesting integrations between Pulumi and our control plane. So before I mentioned, like in our pane, we like had a whole bunch of Terraform. We had to do a lot of generated config. We got around that. So we were able to, in our infrastructure provisioning code, we actually call back to our control plane and say, where should we be running data planes? And then from there, we actually construct all of the infrastructure we need instead of having to create a whole bunch of additional configuration that's stored outside of our control plane itself. So the source of truth for what we deploy, that exists in our repo, in our monorepo, and it also exists in our control plane database. And so when we look at like the state of what our service looks like when it's deployed in production, it's the same whether you're talking about the infrastructure, the application, or how we're deploying Helm charts. Here's a demo of some of that. So let's take a look at how we do our deployments using Pulumi. So our CI release workflow, which is really our continuous deployment, we start off sending some notifications. We deploy and update our control plane, and then we start updating our data planes. We call them Trino planes. That's what the TPs are. Here we have two different sets of matrix updates. One where we're updating some of our more experimental Trino planes where we're running kind of experimental infrastructure. This is a really interesting thing we can do that Pulumi allows us. It kind of gives us the ability to create feature flags that persist all the way down into the infrastructure. So we can kind of have it so specific accounts are scheduled into experimental data planes that are provisioned using Pulumi, and others are running in our regular data planes.
And this is really awesome because it means that we can kind of create these flags that kind of work across our control plane APIs and the actual provisioning code. So if we take a look in here, we've got a whole lot of jobs running that are deploying and updating infrastructure. So a lot of the actual action happens in these deploy jobs. So this is where we're doing a whole lot of work. We kind of set up and configure all of Pulumi. As you can see, there's a lot of steps that we do just to get Pulumi up and running for ourselves. And then down here, I was talking about our blue-green migrations. The way we do this is we get all the way to the point of having everything up and running in our data plane. We mark our new Trino plane or data plane active, and that means that new clusters can be scheduled onto it. And then we start to tear down the old one. We mark the old one as draining, and that instructs our operator and our control plane to start migrating clusters as they're quiesced from the old Trino plane to the new Trino plane, from the old Kubernetes cluster to the new one. So this is kind of how we do our deployments. That allows us to migrate all of our infrastructure using Pulumi from an older version to a newer version without the customers even noticing.
So what's next here at Starburst for Pulumi and the Automation API and all of that? So what we're finding is as our product is becoming more complex, as we're deploying to more regions, as we're building out more and more infrastructure, the need for us to be very precise about how we provision things is becoming more of a concern. We have a really good workflow. It's scaling pretty well for us right now using the Automation API alone, but there's certain components that are a little bit cumbersome, like the fact that we still have to use GitHub Actions to do a lot of this. So what we'd like to do is move to using Pulumi deployments. Pulumi deployments give you a lot of different functionality for basically just running your Pulumi commands outside of having to manage any of your own infrastructure to do that. So you don't have to manage GitHub Actions runners or whatever your CI/CD runners are. You don't have to encapsulate anything in a Docker container. You can just kind of build things using their managed services. So there's 4 different ways to utilize it. The first is click to deploy, which we might be using. We'll see. That's mostly where you can basically define what a stack looks like in a repo and be able to have someone click into a UI and be able to deploy that. The second use case is being able to do things with GitOps, being able to do push to deploy and things like that. And then the ones that we're more interested in using are the Remote Automation API and the direct full-blown deployments REST API. The deployments REST API allows you to take the concept of the automation API and run it outside of your infrastructure. It allows you to do drift detection, very sophisticated deployment orchestration, and ephemeral code review environments. We'd like to use this extensively in our blue-green tooling. So when I think about our journey and where we've been, where we're at, where we're going to, I kind of think about the environment I'm in right now, which is my hangar, where I'm building an airplane. And when I think about building an airplane, I think about precision and having the right tools for the job. When we started off, we had these big clunky tools that definitely weren't for building airplanes. They're more for building bridges. Now we're kind of at a point where we're using pretty generic tools that are very good for building software. They're very good for building standard construction. You can build a house with a Synpact driver, sure. But when I think about building an airplane, I think about being incredibly precise, being at a very, very fine granularity for what we care about in terms of the resources we're creating, how we're creating them, how much parallelism we can get in that. And when I think about that and I think about airplanes, it's definitely the case that the air drill is the precise tool that you need for drilling out all the holes in the skin of an airplane. On the left side here, you have calling out to the Remote Automation API using TypeScript. On the right side, we have the calling the deployment APIs, REST APIs themselves directly. Both of these code snippets just create a deployment based on a Git repo. You can specify, and we probably will be, we certainly will be specifying the SHA, the commit SHA that we want this to be created at. You pass in some environment. It's very similar semantically to the example before using the automation API itself. Let me show you a full demo of that.
We're now going to take a look at the deployment API and the remote automation API. We're just here in my personal GitHub. I have a repo that just creates a Trino cluster with an inside AWS Elastic Kubernetes cluster using kind of the standard Trino Helm chart and Pulumi. So let's take a look real quick at the code. So looking at the stack, we have kind of a standard kind of Pulumi stack here. Usually break up like the functions that create infrastructure from the main.go just as a habit. We really just create an EKS cluster. From that, we generate the Kubernetes provider by grabbing the kubeconfig JSON out of the cluster and then pass that into the Trino Helm chart. This is a common pattern we use a lot internally at Starburst for doing all of our deployments. As you can see, the EKS cluster is pretty standard. Some of this stuff could easily be pulled out into configuration and whatnot. I'm a little lazy, but it just creates a VPC and then the EKS cluster, exports the kube config, and then we install the Trino Helm chart on this. One thing to note is that if you're doing this, I wouldn't necessarily run a whole bunch of queries on that Trino. Typically, we try to keep things on a single availability zone to avoid cross data center or cross availability zone traffic charges. So that said, so that stack works nice and fine in isolation. You can just go into the stack directory and run Pulumi commands from in here, and everything works as normal. So looking at the remote automation API, this is pretty straightforward. It mostly just kind of sets up the stack, references this repository, and then gets an environment going. Of course, these environment variables, I pass them in as environment variables. If you're using some other like instance-based authentication or something like that, or IRSA, you could easily pull these up into, you could easily generate these and pass them in. And then the rest of this code is just kind of error handling. So it's pretty straightforward. If you run it, you get something that looks like this. Here's our deployment. You can see we created 76 resources. Wonderful various components, the VPC, the EKS cluster, and the Helm chart kind of at the top level there. If we look at the deployment, you can see the logs. And each of these steps is really kind of like what you would normally have to do on your own to get Pulumi running within like GitHub Actions or GitLab or any other CI/CD environment. Then really the Pulumi update gets started. This is some stuff that, you know, I believe that as deployments gets kind of matures, maybe this is something that can be cached, but for now it does end up kind of rebuilding the Golang binary every time. But that actually doesn't take too much time. The setup and everything is pretty straightforward. It runs like a normal PulumiUP command. And in the end, we get some outputs. And in total, it only took about 17 minutes to set up an EKS cluster and deploy this Helm chart. Looking over here in K9s, you can see the pods that are running. You can see that we've got a coordinator, 2 workers, and a bunch of additional system pods. We can see in the services that we have a load balancer running here. And that load balancer is here. So we can pretty easily just kind of, this is not a secure kind of environment. This is a very demo environment. There's additional documentation you can read on setting up the Helm chart to put security on top of it. But we do indeed have a Trino all the way up and running.
I'd like to thank you for joining my talk. It's been a pleasure. If you have any questions, feel free to reach out to me online. Here's my GitHub, my LinkedIn. I work for Starburst, so if you're ever interested in coming and joining us at Starburst, also feel free to reach out. We're definitely hiring. Thank you very much.